at the data types that are available in C. So, as we get an introduction to the data types, what is actually data? Data is any raw information which can be represented using numbers or characters. A programmer needs to identify the right type for the right data. If it is a number, it has to be identified that way, and if it is a character or some text, it has to be given that kind of an identification. C compilers support a variety of data types that we will be seeing in the future presentations. The data types are classified in C as integers and characters. Integers are nothing but numbers, as we all know, which do not have fractions. So, the further classification of integers is short integer, long integer, signed integers and unsigned integers. In characters which represent text, we have signed characters and unsigned characters. Now, this float and double represent the fractional numbers. Now, we will see in detail what are the characteristics of each of these data types. So, when we consider integers, we have the short integer. Now, the characteristics can be studied as the memory space they occupy, the range of values they represent, the effect they have on the program execution. So, when we see the memory allocation for a short integer, it occupies 2 bytes in memory, which is equal to 16 bits. So, this is the smallest memory space that can be allocated to represent a digit in C. Now, what is the meaning of this word range? Range represents the lowest possible and the highest possible value that can be represented using this data type. So, a short integer can represent values between minus 327.68 to plus 327.67 and all the values that come in between. Program runs faster when we use short integers. Now, how is this? We know that whenever we have to execute a program, we have to allocate memory for that. And every time we require a data, it has to be taken from the memory and it has to be executed. So, when the memory space that is allocated to a data is less, the memory access time will be less. So, the time it takes for program execution will also be less. Obviously, the program runs faster. Now, the same characteristics when we see for a long integer, we see that it occupies almost double the memory space. A short integer occupies 2 bytes, whereas a long integer occupies 4 bytes in memory, which is equal to 32 bits. So, it can represent bigger numbers. So, if you will see the range of this long integer, the lowest possible negative value is also very high and the highest possible positive value is also very high. So, this long integer is used only in exceptional cases when we have to represent very large numbers. And obviously, the program will run slower because when we define a long integer, it obviously means that it has to access more amount of memory. Now, the next characteristic of a short and long integer as we see is something called a format specifier. A format specifier is nothing but a prior indication to the C compiler about what type of data it has to scan or take as input and what type of data it has to print. It is a representation to the C compiler about the type of data that the program is going to handle. So, %d and %i are used to represent short integers, whereas %d alone is used for representation of a long integer. And then we have the example to represent a short integer. We see we can either give it as int a is equal to 2 or short int b is equal to 15. Now, if you see by default when we give int, it means a short integer. If we have to specifically use a long integer in the program, then we have to go in for this keyword long. So, here we have the keywords short as well as long. These are the keywords that are to be used when we represent integers. So, this is the difference in the way we handle data using integers based on the size that is required for the representation of a digit. Next, we move over to signed integers and unsigned integers. Now, if we will see the characteristics of signed integers, they occupy the same 2 bytes in memory, they represent the same range of values as a short integer, their format specifier is also %d and %i, And in signed integers, we have another classification called long signed integers. So as the name suggests, it is used to represent a wider range of values, and it occupies obviously more bytes in memory. So this is the example for a signed integer, which is represented as int a is equal to 2. And if it is a long signed integer, it has to be given as long int b is equal to the value. So here again, by default, an integer is considered to be a short signed integer. When we consider unsigned integers, obviously we will not be considering whether it is a positive or a negative value. So the memory allocation is the same for this, but if you will see, the range of positive values that can be represented by this is almost double that of a signed integer. This is because the negative values are totally eliminated and the number of values that is represented as negative is added to the positive side. So if you will see the range, it is 32768 plus 32767 all moved to the positive range of values. That is why its range is up to 65,000 on the positive side. The format specified for an unsigned integer is %u, and when we have long unsigned integers, the same thing applies again. The range is almost double on the positive side because the negative values are totally eliminated over here. An unsigned integer holds only positive values. And this is the example to represent or to use an unsigned integer in a programming language C. We have to specifically mention the keyword unsigned, short in C if it is a short unsigned integer, and if it is a long unsigned integer, we have to mention unsigned, long and the variable name. Now these are the types of integers in C that we have seen: short and long, signed and unsigned, short signed and long unsigned.